Composition of functions. Let's just read up here. Not uncommon for the output of a function to depend on some input that is itself an output of another function. Let's have a look at an example. Right, we have an equation here, centigrade. Now, how do we convert Fahrenheit to centigrade? Well, if you remember this from other math classes, here it is. Centigrade equals 5/9 multiplied by F minus 32, where F is the temperature in Fahrenheit. For example, in your calculators, try this. 50 degrees Fahrenheit is 10 degrees centigrade because 50 take off 32, we do that first, is 18. Then 18 times 5/9 will give me 10. Okay, but this is the function notation. But think about here. Do you see this? You can actually, if I'll write a little pen mark here, you can think of this as the F if you want. Okay, so that's me going from Fahrenheit to centigrade. Now, if I know centigrade and I want to convert to Kelvin, this is to do with the absolute zeros, physics, space temperatures. All right, then I've got another equation here. Okay, so right here. Now, what we do is we take the centigrade and we add on 273 degrees, and that'll give us Kelvin. In other words, 0 degrees centigrade, all right, 0, if I put 0 right here, if I add 273, it must be 273 Kelvin, because 0 Kelvin is absolute zero, way out in space, that kind of thing, okay, really exceptionally cold. So, what we can do is then, if I want to just work out what Kelvin is, but I have Fahrenheit and not centigrade, okay, in other words, Kelvin is based on take the centigrade and add 273, well, what I can do is I'll just substitute in what I found earlier for centigrade, and, replace it here, okay, replace this, and I'll end up with this, and that is my new equation. I've put one equation into another, okay? So once we work all this out, we end up with this new equation for Kelvin, okay? That's just you doing the math. But that's just a kind of explanation of what we're going to do. We're going to take an equation and put it into another equation, okay? So replace a function with another function. Let's have a look at some examples. Right, here it is. Read through this. The composition of functions. Okay, now we just say fog. Now what we're actually doing here, so the fog of x, what this means is I've taken the g equation and put it into the f equation. So I'm going to show you what two equations are, f and g, but I'm going to take this g equation and put it into the f equation. Okay, so here we go. Two equations, two functions. Here's the f, here's the g. Right, so fog, okay, means take the g equation, see this, and put it into the f equation. Alright, so for fog, I'm going to take this, here's the g equation, and I'm going to put it there. Okay, I'm going to replace the x with x squared minus 3x plus 8. That's me doing the fog, the f of the g of x. That's up here. Okay, sounds a little funny. So here it is down here, look. So here we go, here's the g equation. Let me get my pen going again. See, that's the g equation, and I've put it where? Remember, the original equation was 2x minus 5. That was the f equation. I've just put this right there. Okay, I want to work it all out. Distributive law, that's what I get. That's the answer. Now, we're also going to do the GOF. Now, what this is take the f equation and put it into the g equation. Okay, so in other words, I'm going to take this. A bit more complicated because I've got to put it there, but I've also got to put it there. Okay, two places, so a little bit more work on this one, but I've got to take the 2x minus 5 and put it into this x squared minus 3x plus 8. Just doing it the other way around. Okay, let's have a look at what we've done here. Okay, so here it is. Remember, this was x squared minus 3x plus 8. That was the original g equation. See, there it is, a circle, right there, right here. And I'm going to put 2x minus 5 into it. Okay, so I'm replacing x with 2x minus 5. So, instead of x squared, I've got 2x minus 5 squared. Instead of negative 3x, I've got negative 3, 2x minus 5. And again, distributive law, work it all out with this, which will simplify to that. So a bit more work. Do remember that 2x minus 5 squared is 2x minus 5 times another 2x minus 5. Don't just square the 2x and square the negative 5, okay?